Hello, everyone. My name is Trey Wadley, and
I'm Austin Bronson.
welcome to our TED Talk about chemistry of brew beering. Today, we'll break down how beer is made and show how chemistry is involved in every step. You're probably curious as to why we decided our topic would be brew beering, and that answer is honestly quite simple. Did you know that beer is one of the oldest chemical experiments still practiced today? It might sound a little strange, but there is evidence, as shown in the slide, that beer was produced at the Göbekli Tepe tribe in 8,500 BC to 5,500 BC, which could mean that people could have been using chemistry to make beer 10,525 years ago. And while that might not be confirmed exactly, it's still crazy to think that people have been using chemistry without even realizing it all those years ago. But moving past that, the chemistry that goes into beer starts off pretty simple. To begin, beer is composed of four ingredients: water, malted grains, hops, and yeast. These ingredients are used to make beer because of the roles they play in the chemical reaction. To elaborate, water is used as a solvent, meaning it dissolves the sugar, proteins, and other molecules needed for the reaction to occur. The malted grains contain starches that are broken down into sugars during the mashing process. The sugars are then used to fuel the fermentation. Hops are used to add flavor and preserve the beer's flavor profile. And finally, the yeast ferments the sugars, which is responsible for producing alcohol and carbon dioxide. Now begin. During the mashing process, enzymes such as amylases catalyze the hydrolysis of starches in the malted grain into simpler sugars like maltose. This enzymic activity is highly sensitive to specific conditions, requiring an optimal temperature of around 60 to 70 Celsius and a mildly acidic pH to function efficiently. We'll go more into the detail of that later. The next stage is fermentation, where yeast metabolizes glucose through anaerobic respiration, producing ethanol and carbon dioxide. This reaction can be represented as the chemical reaction as shown on the slides. And this process includes redox chemistry as glucose is broken down with the presence of oxygen, allowing the yeast to generate energy while producing the key components of alcohol beverages. And now I'm going to pass on the rest of the slide to my partner, Austin.
So next we have the pH acidity process. So during the brewing process, one of the most critical steps is the mashing process. And during this is where grains are soaked in hot water. And the goal of this process is to break down the starches into sugars. This, however, only works well if the pH stays between 5.2 and 5.6, which is slightly acidic. This matters because the enzymes like amylase, which is the driver for sugar conversion, are extremely pH sensitive. If the pH is too high or too low, this process will not work properly. Consistent and constant testing of the pH is crucial to ensure a good brew, which is something we have done in class. We have made acids less acidic by adding in bases, and that is what brewers do is by adding in bases like calcium sulfate to adjust it. And the next we have is the carbonation process. This is actually carbon dioxide, which comes from the fermentation process when yeast turns into sugars. The CO2 only dissolves in cold liquids and when it's under pressure. The gas solubility increases with pressure, and that is why beers are sealed and kept in cold. The CO2 needs to be under constant pressure. When you open the bottle, the pressure drops rapidly and the CO2 escapes, which then forms the bubbles that we see. So next is just the overall chemistry of beer. Beer is essentially a solution of complex molecules that all influence the beer taste, color, and the overall feeling in your mouth. The taste, such as bitterness, comes from the acids, which become water soluble during the boiling process. The color is a reaction between the amino acids and the sugars when it's heated. And then the alcohol, which is ethanol, is an organic compound that affects how it interacts with water and then how it feels in your mouth. Which that concludes me and Trey's TED Talk on beer brewing. And we have a bunch of our sources here at the end. And uh, me and Trey have collected all of these. And just thank you for watching.
Thank you.